Wonderful people, it is time to get started with this week's DBA Fundamentals, this time with advanced insights into System Versioned Temporal Tables with the great Uwe Ricken. Ricken? I'm getting there. One day I'll get it right. All right, so today is April 26, 2022. As we get started with this wonderful presentation, before we start though, let's go through our normal stuff. In the upper right-hand corner of the screen, you'll see the three leaders of the group: Steve Cantrell, Shane O'Neill, and myself, Kevin Wilkie. To the right of our names, you can see the easiest way to get hold of us on Twitter. Below that, you will actually see the many ways you can connect with the group on social media. The first one is on Meetup. As you can see, we have our own Meetup page, and most of you probably connected to us through there. Below that is our website, dbafund.org, the best site on the web for any of your DBA issues, questions. We have lots of our past presentations as well as our upcoming presentations linked out there for y'all. Below that is our YouTube channel. As you see, we've already renamed it to DBA FunTube. Make sure that when you're on there to hit the subscribe button so that when our latest presentation will actually go out there, you'll be one of the first to know, and you can watch it and review and do whatever you'd like to your heart's content. Below that is our Twitter handle, DBA Fun, and then our Slack channel and LinkedIn group. All sessions are recorded and are usually available within 1 to 2 days. As always, it'll be posted out there on dbafuntube.com. Remember to turn off your video screen and actually remember to mute yourself so that it won't interrupt our presenter. Also gets all our bandwidth going straight to our presenter, which is obviously the most important. Also, be sure to type any questions you have into our chat window, as that way we can keep up with it and you won't interrupt the speaker as well. And with that, we go over to Uwe. So with that, all
Thank you. Yeah, I'm fine. So I think that I will start sharing my screen. Yes. You can see this, just give me a second. So we did the tech check, everything is working well. So first of all, a good evening. Say evening from Germany. We are 6 hours ahead of you, so it's 6 o'clock in the evening. And I'm really happy to introduce the temporal tables, and that is the cool thing here. The let's say the secrets of temporal tables, where you will see that temporal tables is not always the very best, because there are a few pitfalls with temporal tables, and I was collecting them. And I was when I was with my customers and playing around with that, we were quite often stumbling over some problems with the temporal tables, and I collected everything and said, okay, let's make a session out of it, because I think it's quite interesting to see what you can do with temporal tables and what not. So here is the topic. It's called Deep Dive into the Secrets of Temporal Tables. Kevin, you have the links to the scripts and the slides and to the demo database, what I'm using here. So I would say, yeah, enjoy, and please, if I take a few more minutes, because I tend to expand my limits, I hope that the stuff will be so important for you that you say, okay, it's worth the few minutes over time. Good, let's start with this. Some words about me, but very short and simple. Forget about everything on the left side. That's only commercials, because I want to earn money. But if you have any questions concerning temporal tables, just drop me an email. Feel free to drop me an email, and I'm quite happy to answer your questions. And yeah, I'm a secret Microsoft certified master, blah, blah, blah. That was long time ago. In between, I'm now a few years older, and I'm a Microsoft MVP. I'm quite happy to be in this great community. So this is our agenda. It's very simple. It's very easy. Oh, there is someone has a camera on. It's Kahan. Yeah. So maybe that you take care of the camera. So First of all, we do a really cursory introduction to System Versioned Temporal Tables. I want to show you how that works, what requirements you have to fulfill, what you can use and what you cannot use. And then we come to the troubleshooting System Versioned Temporal Tables. That means that when you are working with System Versioned Temporal Tables, you will see here some situations where you as a DBA or as a developer, because temporal tables are more developer stuff, it's not so often a DBA stuff, you can see how you can handle a few scenarios which we were running into problems. For example, nullable attributes. So when we're talking about constraints, what is about metadata operations? So what will happen, can you easily adding or dropping columns in tables when they are system versioned? What is about changing data types in tables? How do you have to handle this? And what is about renaming columns or tables? And that is really fun. So another big problem, especially when you're a developer and you love to work with triggers, then I can truly say, do not do this. Triggers in System Versioned Temporal Tables are truly a nightmare, and I will show you why. So we have a new security features, or let's say security features, which can work with temporal tables. It's dynamic data masking and the row-level security. And the last two topics, they are quite interesting, calculated attributes. And we have, and this is the most interesting thing, long-running transactions in conjunction with temporal tables. That can truly be a nightmare. So let's start with a short introduction, because I think that most of you are familiar with temporal tables or have heard about how that works. But let me give you a short overview with a short demo about what is temporal tables. Well, temporal tables is a new feature which has been first introduced with SQL Server 2016. And everybody was saying, hey, hooray, that's so cool. Yeah, I was in the same mood and I said, yeah, that's cool. That's what we want to have. The good thing with temporal tables is, especially when you are a developer, then you know how hard it is to track changes from a specific table. So what we did before temporal tables was we created a second table, and then we were handling the system versioning with triggers or with stored procedures. It depends on how we access the data. The good thing is with temporal table that it keeps a full history of data changes and allow a point-in-time analysis, and that is what we want to do with temporal tables. When you have a look to Amazon and or for any other website where you can see the development of prices within the last 3 months and all this kind of stuff, that's coming, or that is a reason to use temporal tables. A temporal table contains a reference to another table with a, and this is important, mirrored schema. First big requirement for temporal tables. The shadow table, let's call it this one, or the mirror table, must always, really always have exactly the same metadata. So the same data types, same columns, column names, and so on. The system uses this table to automatically store the previous version of the row. And the good thing is, when you read this automatically, it really is automatically with all its good things and bad things. Because when we are talking about storing data in a second table behind your normal transaction, be aware that the storage of the data in temporal tables is inside your user transaction. So as longer your normal user transaction takes at the time for bringing the data into the temporal table that belongs to your user transaction. The operational area of temporal table is very short. So analysis of data in relation to historical data, which is required from the business. The second thing is way more important, especially for my business cases. I'm working here in Germany quite often for German banks, insurances, and for big consulting companies. And one database where I was called to because I had some problems with was a forensic database, which means they had very sensitive data in their databases, and they always wanted to track who is changing data and what were the data before. So that is one really important reason to use temporal tables, because temporal tables are protected by the system. Another point is the reconstruction of data to a dedicated table to any point in time. I think few of you I was running into that problem. Have you ever been in the situation you wake up in the morning, you forgot your coffee, and then unfortunately you typed delete from table without a where clause, bang. Yeah. So with temporal tables, no worries. The first thing is you grab your coffee and then you start to get your data back from the temporal tables. Calculation of trends over a predefined time period. That's what I was talking about when we go on web pages where you can see the development of prices within, let's say, the last 3 months or last 6 months and so on. And that is where temporal tables could very good fit into your business. So how do temporal tables work? And so to be honest, this is a very, very simple thing, especially when you ever had in your lifetime develop your own versioning of data, then you can understand how Microsoft is doing that. System versioning for a table will always be implemented as a pair of tables. So that means you see one table, but in the background there is another one which stores the historical data. What is required is that we need to have 2 additional attributes with your data. They must have the date time 2, and they store the validation or the range of day in the date where or from what the data was valid to what timestamp. They are used for the temporal validation of a record. And here comes a very cool point, and this is something where Microsoft was thinking about. These 2 attributes can be marked as hidden. The question was, what I was always, people coming to me after the session was, hey, why do you do that with hidden? The reason is very simple. Whenever you have vendor-driven applications or vendor-driven databases, try to ask them to add to their schema 2 additional attributes. They will laugh very loud to say, hey, what do you think about this? If you want to do that, then you lose the guarantee that we can assist you. But with the hidden attribute, you can trust that the application will work as expected, as it was working before. Because the good thing is, when we mark these attributes as hidden, they are not visible to the application. And that is a really cool thing. So that means when you have a vendor-driven application with a database coming from the vendor, just only if you want to add temporal tables, and you add these both required attributes, and you mark them as hidden, and that's it. And then the application will run with no breaks. And here comes the hard stuff. You have to fulfill requirements or constraints to use temporal tables. The first is very easy, but not always. Requirement is to have a primary key constraint. And the history table must have the exact same metadata. Third point. The history table must not have constraints. So when you think about develop your own history table and say, well, yeah, I want to have a primary key or foreign keys or defaults, forget about this. This is absolutely not allowed because SQL Server must be sure that there will be no constraint which will prevent SQL Server to store the history data into the temporal table. And then we come to another really hard point. Constraints are truncate tables not allowed. And that is a good thing because what is truncate doing? Truncate, maybe if you have read blogs, you will definitely know that truncate is a DDL command which deallocate data pages, but not will do a delete row by row. But this is required for temporal tables because when you delete data from a table, SQL Server must take the row, and before it deletes it, it must push it into the temporal table. So therefore, truncate table is not allowed. The second point is quite cool, and that is required. The direct manipulation of data in the history table is not possible. It's protected by SQL Server. So as long as your table is part of system versioning, You cannot change data in the history table. Delete and update cascade is not allowed when the table is in detail, is the detail in a foreign key relation. But this is a very, this is something what you can have a good workaround is instead of triggers cannot be used. But I will show you a trick how you can use it. And file table cannot be used, but that is okay because file table does mean that the data are not stored in the database, but get managed in a file system by SQL Server. Let me show you how the requirements for temporal tables are working in real life. So what I will do is I have my demo database. By the way, in the background, there are a few the running job, which is permanently changing data because I want to run queries against the want to run queries against temporal tables. Here come the requirements. I have a database called customer orders, and you can download this demo database from the web link what Kevin has. So the first thing what you should do, and this is good practice, separate your history data from your production data. The best would be to put it into a separate file group. So, and then what I'm doing is I have now a file group called history, and I add a database file to it. That's it. That's only the preparation. Next thing, good practice. Separate the temporal table not only on the physical area of the SQL Server, but do it with schemas the same way. Have a dedicated schema for your history tables, and that's what I'm doing here. I create a schema called history, and then I create here my shadow table where I want to store the history data in. What you can do is you can create your own table because of the naming. That's for me the most important thing. Or what you can do is you can let it do by SQL Server, but then you get funny names out of it. Yeah. So that is the reason why I do it manually. I want to see what I'm doing and don't want to see behind the curtain what is SQL Server doing. So this is my address table, and you see here ID, street, country code, zip, city, state. And if you have a look to the original table, you can see that now the schema is a one-to-one match. Here is my ID. This is the street. Take care about the requirement that the metadata must be exactly the same. You are not allowed to do it wider or shorter or take an n-bar chart instead of a bar chart. This all must be exactly the same. So you see here that now my metadata of my now prepared history table is exactly the same as it is from the table I want to use as system version. So now comes the easy part. I'm a beginner and I heard about temporal tables. Let's see whether we can do this. So I tried to enable system versioning, and therefore I need to change metadata. And what I'm doing is say, please alter the table DBO addresses and then activate system versioning and use as a history table my previously created table history addresses. So let's give it a try, but it will fail. Because first requirement does not match. Whenever we want to have system version temporal tables, we must have two columns where we store the validation of the data. So we need a start date, and what we need is an end date. Okay, lesson learned. Let's do this. So I go into my original table in the dbo.addresses, and I add two more columns. The first one is the start time. Have I look at the data type? It's not a date time, it's a date time 2. Okay, it's ANSI standard, and take care of that. So what I say here is I want to start with all my addresses at the 1st of January 21 from the validation point where it starts. And I say they are valid to the end of 9,999. I think this is okay. And let's do this. Now, when I refresh my columns, you see now I have the start and the end time in it. Yay, everything is working fine. Let's try it again, but we will fail again. Now there is another requirement which has not been fulfilled. I must have a primary key on the DBO addresses table. So here I will have a primary key on the ID. And this can be a problem if you want to add system versioning to vendor-driven databases. If they do not work with primary keys, I saw lots of applications which are not using primary keys, then it might be that you cannot use this because it is required to have primary keys. However, here I know that it will work. I add my primary key to the addresses. And now we'll look to this and you see here, now we have the primary key in it. Let's try it again. Here we are, but now we got another error, and this is absolutely clear because what I did was I have added these two time columns only to the original table, but not to the history table. And that is what SQL Server requires. It say, well, sorry, Uwe, you have two more columns in the DBO addresses, but they are missing in the history addresses. So make sure that the metadata will fit. And that's what I'm checking. Therefore, I run this query. It's very simple. What I'm doing is I say, please give me all the columns I have in DBO addresses, which I do not have in history addresses. And it now spills to these two columns, say, well, sorry, Uwe, you need to have start and end time in your history table. Okay, let's do this. Done. So now in my history table, I have exactly the same schema. Here is my history addresses. And please note, for people who are not so familiar with temporal tables, have a look to the following, but that will change. If you look into tables, you see that the table which I want to use for system versioning is in the hierarchy directly under the container table. So it does mean that SQL Server in the actual situation will handle the history addresses as a normal table. So now everything must be okay. I think that I have all my columns. Yes. What? A moment. Yeah, okay, they are in. Okay, so now try to do this and go. Oh, done. So now system versioning is activated. I have fulfilled all requirements, and now my history table is a very special table. When I refresh my table, you will see two changes. First thing is my history table is gone. Second thing is that when you look to the DBO addresses, you will see this tiny little clock here. And that does mean that now the former independent table history.addresses is now under control by this one. And you see now that this formerly independent table is now part of the construct of my DBO addresses. And that is not that now the history table is fully protected by SQL Server. I cannot do any changes there. Let's see how this will work. So first thing is that I say, please give me the address with the ID number 2. You see, this is the address, and it is Arlington. So let me do something like this. I need to change it. So and now I change the country code. And when I change the data, it normally will only address the DBO addresses. But what happens here is that now when I run my normal queries, you see, well, yeah, that has been changed. But what is behind the scene? Let's go to another thing. Let's do it like this. So I update now my address with the ID number 1. And then I delete my address with the ID number 3. So a short sum up. I changed address number 2. I changed address number 1, and I deleted address number 3. And I can prove this by evidence. When I run a select against the DBO address and say, give me the address number 3, it's gone. But here, when I look into the history table, and that is interesting. Oh, what? Stop. Well, I did it. 1 moment. DBO addresses. What's going on here? 1 second. 1 moment. Oh, okay. Let's take this one here. Okay. So you see here, let's concentrate on the update. It's okay. What you can see here, and this is where I want to draw your attention to, have a look to the start and to the end time. What you see here is this one was the very first address that was valid from the 1st of January 21 up to the 26th of April 22. And if you look to the timestamp, please note, very important, that system versioning will only store data in UTC because, and that makes sense, you want to query the data all around the world. And the next thing you need to be aware of is that when you look to the end time, that means at that point, this record was not valid anymore. And then we have this one here. And if you look to this, you can see that there is absolutely no time gap in between. And this is required, but there is just only 1 second in difference. Then SQL Server cannot close the chain and will not detect this row as a predecessor to this one. Yeah. So the time is not allowed to be there is not allowed to be a gap in between. So let's look for this one. Select from DBO addresses. So you see that I have changed it. Here are my changes. And that is a good thing because the normal select statements from your applications, they're working as before. So also we did do some metadata changes in our database. The application can work. It is not being aware that we now have implemented a background process which will store all the data. So when I try to change it, think about this. Someone has changed data and you say, oh my goodness, I changed data, but no one should know this. Let's delete the history data. That cannot be worked because it is protected by the DBO addresses. To change it, that you can manipulate data in the history table, you need to have the alter privilege because then you are able to stop versioning, do the changes, and implement the versioning. Otherwise, if you're a normal user, you do not have any chance to delete any data from the history data. So that it is, and I clear table, everything is fine. So let's see, no questions, that is good. That is a good point because then I think so far, temporal tables are very, very easy. So these are requirements. Take note of them when you want to play with them around. These things what you have to fulfill. When you create a temporal table, you have 3 different ways to do that. The first one is to do it with an anonymous history table. To be honest, I'm quite open to this. That's not the best way because sometimes maybe you know this. The funny names of renaming from Microsoft, by the way, the temporal table, they did a pretty good job, but don't use anonymous tables. Be always aware of the objects and the names of the objects you will have in your database. As easy as Luke, system versioning of, as easy as turning off system versioning off to suspend history. Yeah. So the definition of a name of a history table makes more sense. Here comes the good point. If you say, please create the temporal table, and I give the name for the history table, and if it's not existing, then it gets created automatically for you. That's the easiest way, and you have the good thing that you do not use anonymous tables, and you have a named table which gets automatically created. You do not have to make sure that the metadata are correct, are exactly the same. Or, and this is the way how I'm doing this, is that you previously define a history table which you then will bound into the system versioning. One of the good things is when you use option 1 and option 2. So that means that SQL Server will create the objects for you. It will use data compression for the clustered index by default. Normally I would say, what do you think about this? But data compression is, from my point of view, it is a really cool thing. Is there a question? Because there is a mic open? No, okay. The data compression, from my point of view, is a very good thing if you do not have a high transactional system. So data compression requires CPU because it needs to compress the data when it stores the data. It needs to decompress the data when it reads the data, and so on. So you have to test it out. Normally, data compression is a cool thing, which I really like. But if you have heavy loads on your database, think about not to use this. But if you use temporal tables with the option 1 or 2, that means that SQL Server will create the history table for you, then it gets automatically using compressed clustered index. So how can you create a temporal table? That is very simple. The only thing what you need to take into account is that you have these two additional columns for the start and the end time, and you define them as generated always as. The row start does mean that is the data point where it starts when the validation begins, and the row end does mean, and that is the timestamp when it is not valid anymore. The next step is that you say that these both columns are the period for system time, start and end. And with this one statement, you can definitely say, okay, I want to have system versioning on, and optional, you can say, I want to have a history table, which is this one here. If the table does not exist, it's fine, it gets created for you. If the table exists, then make sure that the metadata are exactly the same. What is the best practice for architecture of temporal tables? So to be honest, it depends. It depends on the requirements. And there's one question, sorry about this, we'll interrupt you. System time is in local time or UTC? So the answer is, Sam, it is always UTC. And if it is in UTC, then can we use local time? Yes, you can. Let me show it later on when I show you the select statements. Okay, you have a possibility to do that. So best practice for architecture of temporal tables, as I said, that depends on your requirements. What I'm doing is I'm separating the history data from the normal processing data. What I'm doing is normally with the database, so I have a separate drive and a file group where I have my productive columns, tables in. And what I then do is I will have another one where I put in a file group history and my schema history, and the customer data or the invoices data, they are located on this other file group. So I separate my normal data from my history data. The good thing here is, for example, if you say, well, temporal tables is a good thing, but I don't want to throw money on the storage, you take a cheap one. Put it on a different drive with a cheap storage, put the file group on, put the database file on it, and then you put the history data on this cheap disk. On the other hand, you have the option, if you have a high transactional system, take the most expensive storage you have, put this at the drive as, and then put the history data on this one. David, let me show this later on to you, yeah? So the question is, how do we include username who updated it? if going through web and so on. Yeah, I will show it later on because that is a part of instead of trigger. So what you can do is, and that's all what you can do as a developer, is protect your data. Just only allow dedicated group of people to access these history data. That you can do with normal groups, database roles, and so on. Query. Hey, yeah, now we come to a very interesting point. You know that when we have temporal tables, we have two tables. The first one is where the actual data are living, and the second one is the history table, which gets automatically the former version of a record when we run an update or an insert, but not an update or delete, sorry, but not an insert, because insert does mean we have a new data. The good thing with the temporal tables is that you can run your regular queries on the current data. So all of these queries, what you're running, don't worry about that. You can run them the same way as before. Yeah. So if you want to run queries against the history table, then you have a dedicated syntax for this. You run this with the for system time. And you see this here in this slide deck, for system time. But I don't want to do that only here in theory. Let's see how that works in practice. And this will answer the questions of Sam and maybe of others. So I close this. You see here, one moment. So you see here that in the background, I was really heavily changing data. So every half a second, I change one row. So I think I started around 5. So 1 hour changes now. And now I stop this. And we can check what the actual situation is. So now I stop this. Querying is the point. So this is the query number 50. So if you want to replay this, I go into my customer orders, and then this is only a cross check. I want to see how many example data I have gathered in this 1 hour with the background process. So this here is my ID, so my address ID, which my employee ID, which I changed. I had 81 changes. I take the number 60 to demonstrate everything. So set statistics and IO and time on for a developer, a very important thing. We want to see how the system is working. And here is, first of all, the answer for Sam. The question was, how can we use local time? Very easy. Use the add time zone, and then you add yours to this. And then it gets automatically calculated to this. Okay. So I have the employee number 60 where I have, come on, where I have 81 changes. And let's do this one. Run this query. So you see that is very funny names. I changed it, funny address, and so on. I have 82 rows here, 82. And that is what you see here when you run a query against the historical data. You have to use this for system time. That is always required in that moment when you access the history data. The all does mean, give me all the changes I've made to this one record. And let's have a look to this. I execute this again, and you see here what I have mentioned before. Look to the timestamps. This one here is the actual one. And you see here, this is my timestamp, yeah, plus 2 hours. So it means it's a 6:30 p.m. here now. And once again, you must take into consideration that the time chain is not allowed to be broken. So when there is any gap in between and the chain has broken, then all the data which are in between cannot be used with these queries. Yeah. So Next thing, one stop, I forget is something. Look about this. And this is something what I really, really, really want to draw your attention to. Look to this. I run a query on the system versioning, and that's okay. It's taking two different tables. The first one is my regular table, the employees table, and you see that it's using a perfect index C. That's because I'm running a query against the primary key, the ID. And that is okay, but look to this. This is my history table. Also, I only have 81 rows getting back. It is running through my complete history table. Here it is. So because that is because of, from my point of view, the clustered index of the history table, which needs to be, no, this one here, sorry, this is the history table here. This one is the original one. I see that, Sam, yeah, or Rahi. Yeah, the base table is this one. But when we use the query or use the system version, so here for system time, then it needs to access the history table the same way. But the problem is when you create, let's say, temporal tables out of the box, then it could be that the index is not well designed for your purposes. The point is that the clustered index on the history table is only on the valid from and valid to, but not on the ID. Let me show this to you, how that works, because that is a push-down predicate. What the, oh, sorry, one moment. I want to use the 60. So go for this. Here you can see what SQL Server is doing. We have a filter here with push-down. And you see that SQL Server is running through 9,500 rows. And here it comes to the filter on the ID. You see that here that we say that the history employees ID must be 60. Another thing what is quite interesting is that you can see that valid from and valid to is not allowed to be the same. They must be different from each other, but there's a reason behind that. So now I come with 9,500 rows, and I'm coming back with 81. And they get concatenated, and then we get streamed them to the client. So you see that in the history table, that the index is not always the very, very best. But how will you run queries against the history data with a dedicated time? So what you have to do then is, for example, this one here is telling me what was the situation or what was the status of my record for the employee number 60, especially on that date here. So what I'm doing is I'm calculating here 30 minutes back. Say, okay, this is one little typo, so like this. So go 30 minutes back, and then what was the situation with this record here, number 60, 30 minutes ago? Therefore, I'm not using for system time all, but here I'm using for system time as of point in time. Now I get back this one. This was the situation 30 minutes before. Yeah, and you see here, that was the timestamp. At that time, it was here valid from. This is the criteria. This is valid from. So that means from 4:13 to 4:14, this was the valid record. I'm 30 minutes back, and that means at that timestamp, this one was the valid row. So what I'm doing now is I'm changing my index on the history table to improve the performance, because I always run queries against the ID, and the original one is from the valid to and valid from. So I add, or I change my index to the to a better one that I run a query against the ID. What? Oh, come on. Come on. No, no, no. And this is something what is, one moment. Excuse me, this is live. This can be, but let me show this. That is the name. Okay. So, okay. So now I've changed it. Let me save this. Okay, and run the query again. So I get 30 minutes back. Run the query again. And now I get a way better plan because now I have 2 seeks here. Yeah. That is a better one. So, but that is something what you always have to decide by yourself because that all depends on how you run queries against your data. I think that in a data warehouse, the patterns of queries are way different from an OLTP system. You can run queries in a time range. That means that you say, give me the data, how they were 10 minutes back for then the next 20 minutes. So that's what I'm doing here. I go back from a start date, 30 minutes, and end date, 10 minutes. So that means that I will run a query against a time range of 20 minutes where I'm going 10 minutes back. Go for this. And again, with the number 60, and you see that is normally not the usual thing, but I change every half a second a row. But here you can see it very clear how that works. So I'm going back 10 minutes, and then I take the next 20 minutes to see what changes I've made to the data. The really good thing is my index, because now that works pretty good. I have an index seek on it on both on the history and on the regular data, and that is way more professional than before. The contained in does mean that everything what is in this start and end date, where any changes were in this area, in this time area, one moment, go again for the number 60. This is something what is a little bit annoying, but this worked the same way. Contained does mean that what is in this time area, and that's how you can work with querying temporal tables. Yeah, I know, but that's okay. So here is a short workaround how that works. You create your table, and if you want to use that for system versioning, you can put these statements directly into the create table, or what you can do is you alter your table, so that means that you add system versioning after the objects have been created. Then you run your normal insert, update, delete, and merge, but have a look to this. Insert does not affect temporal queries or temporal tables, because an insert does always mean there is just a new row. We do not have any history about that, so that will not affect your workload if it comes to delays because of a higher transactional volume. Another thing concerning transactional volume, keep in mind, what effects will it have if you have always on availability groups? Test this before. So if you run your queries, pretty cool thing, you can run your queries the same as you do it all the time, because whenever you run your regular queries, it will never ever affect the history data. They never get touched. Only if you want to have temporal querying, you use this for system time, and then it gets it's using the history tables. These are the options what you have for system time, for time as off, giving a dedicated timestamp from, to, between, contained in, or all. But here comes the point. What can go wrong? That will go wrong. That was the basics of temporal tables. And now let me show you what problems you might have when you're dealing with temporal tables. Here are some questions for you. What is about nullable attributes? So you can run into trouble with system versioned temporal tables when you add nullable attributes. What about metadata operations? When you're adding or dropping columns, something like this. So nullable columns can be a challenge. What will happen if you're changing the constraints of your tables? Null becomes not null in an empty table. Null becomes not null in a filled table, or not null becomes null in a filled table. Let's see how that will work and how that will affect your system. So the demo number 60 will demonstrate this to you. And what you see here, I have a wrapper store procedure. By the way, let me shortly explain what it will do. This wrapper function here, a wrapper store procedure, will create a demo table for me. Refresh this here. So what I'm doing here is I say, please create a demo table. It's called customers in the schema demo. And the create table say create it. And then it takes it automatically into system versioning. I leave it empty and I don't want to remove that. So let's run this. Demo table has been created. And now you will see here that demo.customers, it's automatically in system version. The reason I'm doing that is if you do that in demos and you want to handle lots of demos, then it doesn't make sense to have a 100 row demo where you have to scroll down and up and so on. So I covered everything as a stored procedure. Here comes the first point. Null becomes not null in an empty table. The demo customers has a history customers table as history table. I start my transaction, and now I run this query. Normally, if in a face-to-face workshop or session, I would ask you directly, what do you think? Will it work? And here I will answer it directly. The question is, yes, it will work because my table is empty. So the demo customers table is empty, no data in it. So the same with the history, there is no data in. So this is the reason why it will work. But look what SQL Server is doing, and that's quite interesting. What I'm doing here is I'm looking into the transaction itself and want to see what object SQL Server has blocked for this alter table. If I execute this, you can see here, forget about this, these are system objects, but this is an interesting thing. The demo customers has a schema modification lock on it. So that's clear because we are doing metadata changes. We are required to have a schema modification log. Same for the history customers. And that is the most important thing for you to know. Whenever you do metadata changes on a regular table which has system versioning activated, it is required to apply these changes directly to the history table in the same way. There is no chance to break this chain. Or there is one, you will disable versioning, but that doesn't make sense. So SQL Server has blocked the demo and the history table for this modification. And there is just only one statement for this. It does mean that SQL Server makes sure that the metadata will be exactly the same in both objects. Commit the transaction, and let's go. I now have the following situations. Look to the columns. Refresh. Here is my phone, which I have added. I said it is not allowed to have that nullable. So now I insert one row into the customers table. Works. The good point here is, well, okay, the phone number, I gave it, so it will work. Here is my data. And here is my, come on, my phone number. Okay, so now we are thinking about the following situation. Say, we do not need an email address every single time. Let's make the email address not null too. So that means that we want to have always an email address in it. The question again is, will this work? And the answer is yes, it will, for a simple reason. The rows we have in the customers will all have an email address. So when it comes to the check, it will automatically go ahead and say, well, okay, everything is fulfilled. Every single row has a valid text in the email address. And the good thing is, when you now think about that we have to apply these rules to the history table, no problem, because the history table is empty so far. So that is the reason why this will work. So you see, now it is not null. So now I take the email address and ask for, it should become null again. One. Execute. And now I insert a new row into the customers table, null. And I think, to be honest, you know what will happen. This alter will now fail because there is one row where we do not have an email address. So it say, well, sorry, Uwe, but you cannot do this because I have nullable rows in it. No worries, I say. Oh, come on, make an update on it. Give Microsoft an email address because they have two less of them. And now try to do this again. The question again is, will that work? The answer is no, it won't. Also, now we have fulfilled all the requirements in the demo table. We have a problem now in the history table. Because in the moment we did the update, the old record where we didn't have the email address is now moved over to the history table. And in the history table, we now have a record with an empty email address. When it comes to changing the metadata, it will not change only the demo, but it will change the history table in the same way. And that will fail. It say, well, sorry, but in the history table, the requirements we need to have have not been fulfilled. The column does not allow nulls. Sorry, no work. And this is what we see the data. Here is my Microsoft company that's in Germany. And you see here, this is the history data, and there is an empty email address. So that was valid up to this time. And from here, this is the actual row. And we cannot add this. So make sure when you change these metadata that you always take into consideration the history table. It might be that you will see, well, it must work in my regular table, but maybe these constraints you want to apply to the table does not match the requirements of the history tables. So I remove the data and everything is clear. Next thing. Metadata operations. Ho, ho. Yeah, that's funny. Adding or dropping columns in tables, changing data types or renaming them. Ooh, very, very cool thing. Here comes the demo. Let's close this one. Take the number 70, add, and drop columns to tables. So what I will do here is I now create my demo customers again, but now I have data in it. Okay. So has been created. We have 87,000 rows in it. And now I do a few changes. I run 1,000 changes here. That is only for the reason that I will have a few history data. Okay. Here comes the first thing. So our table now, refresh, will should have a new attribute called facts. So that must be a varchar 20, and it is allowed to be empty. We'll do that. Done. So far, okay. And now I run an update on it. So a few thousand rows will now be updated. So the fax number of these customers, let's see how many they are. I don't know, but okay, that must be a few thousand. And now the fax number is Okay, let's see how much data we have. One moment, let's update the cache. Here is my fax number, and I want to see all changes for the customer with the ID number 100. And I hope that this one is, yeah, this is him. So here you see, this is the original row. After this, I ran an update on it. This is the actual one. So this is the former presentation of the row where it didn't have a fax number in it. Okay, now comes this one, and this is very interesting. And by the way, I really complain about this. The reason is very simple. Look to this. I say, please add a column called mobile. It must be a varchar 20, not null. Here comes the point. When I say it is not null, there must be, from my point of view, a contradiction to the statement that the history table must have the exact metadata. That will happen. But for the now stored data in my history table, we do not have any email address. Yeah, so a mobile number, sorry. So I see this here. That's funny. You didn't see this. So, okay. So, but what SQL Server is doing, and this is something I do not really understand, is when you add a default to it, it will work. So, to be honest, what we are doing now here is when we look into the history table, we have a record situation, which is, for me, by definition, not true, because at that time, we didn't have this information. And a not given was not the status of the record previously. However, let's do an update. So I run an update. New rows will be updated. And now I see what's going on. Let's go for the number 100 again. And you see this. Here is a mobile number not given. But keep in mind, at that time period, we didn't have a mobile here. We didn't have the situation that the row was in this status with a not given text in it. From my point of view, not the correct way, but however, that's how it is implemented. Next demo, what about this? An alter table. Now I add another one, the pager, which I say, which is a varchar 20, not null. To be honest, that cannot work. Yeah, but that is something which has nothing to do with versioning, but this is a typical design problem because we have data in our table, and if you say they don't want to be null, then it does mean, first of all, they must be empty, or you have a default value for this. Otherwise, that won't work. But what about this? One moment. Yeah. What about this? I want to drop a column. And you see my warning. So that include for you that I do not have to ask you, hey, will that work? Sure, it will. So it does mean when I now drop that column, sorry, what is this? One moment. Yeah, here it is. It's gone. So my email address is now away. And to be honest, what I really would like to see is that as long as the table is in system versioning, from my point of view, it definitely must be prevented to drop columns. That must be a, how do I say, that must be a process where if I want to do this, I must be clear about that I will drop historical data. I will change my historical record status. And that means for me to prevent this way of working it, stop system versioning, and then you drop your column because then you really know what you do. there are so many people who were really concerned about that, and they said, oh my goodness, I wasn't aware that it will work, so I dropped my column here from the table, and it was going away from the history table in the same way. And I said to them, well, okay, if you don't want to have this, then use CDC. Change data capturing will not allow this that way, so it will store the data anymore. Let's see how it is looking for. So you see that I do not have an email address anymore. And when I try to run this query again with my email, it doesn't work because it says, well, sorry, there is no email anymore in the table. That's really bad from my point of view. I wish that Microsoft will implement these kind of metadata changes a little bit more restrictive. Say, okay, you want to do this, then you must be clear what you do, then stop system versioning and then do what you want. What is it about changing data types? That can happen all the time. So especially when I remember that when I was a developer, developer means I was working 3, 4, 5 years only for doing database development. And I had it so often that we need to change data types and tables because of different requirements. So let's see how this will work. Changing data types. So what I'm doing now is, let me see this. Yeah, I come to 150. That's okay. Go into my customer orders and create again my demo table. So I have 87,000 rows in it. And now have a look to this one here. This query gives you an information about the metadata. And you can see here that we have different columns. So for example, the name is the varchar 100. Then we have the street, which is a varchar 100. And what I want to know is, what is, also I'm storing here 100. What is the maximum length I'm actually storing in name, company name, and in street? So keep in mind, both have 100. And what you can see is that the company name is, the maximum is 39 characters, while the street name is 35. So here they are. Now let's do this. Can I reduce the column name or the number of characters for the name to 50? The answer is very simple. Yes, we can. That's very easy because for one simple reason, we have 39 characters, 50 is okay, so it's more than the maximum entry, and we do not have any data in the history so far. The second one is, can we reduce the data length for the street from 100 to 30? And the answer is very simple. No, we can't, because the street has 35 as a maximum, and that would be truncated. The good thing is, when we're doing with 2015, you can see here, normally it should be that it's a, well, the truncated value, here it is, yeah, say it's empty, however. So now, we cannot change it. The maximum for the street is 35. Now let's do this. I now make an update on the demo.customers for one single row. I make the street a 60 character long entry. Go for this, just for one row. And what has happened? The row with the number 10 has now produced a history entry. And the history entry has the original street, how it was stored before we changed this. And this is what we can see here. This was the previous one, and this is the new one. So this maybe was 30, 35, and here is the validation. It was up to 508, and from 508 till now, this is my valid record. So far, so good. Keep in mind, this one here is in the history table. Now we reduce it to 30. Done. Can we now change the column to 30? Can we reduce the length from 100 to 30? The answer is very simple. No, we can't, because now we wouldn't change, we couldn't, so normally it would fit because that was the 35 characters, but now we have the problem in the history table. Yeah, so it does mean here that we always have to take into consideration that we store old data with the original length in the history data. So what can we do? And this is what I would like to see Microsoft implementing, dropping columns the same way. I now go for switching system versioning off. Now I change the customers table, the production table, and set it to 30. So now comes the stupid thing. I want to implement or want to start system versioning again, but it's clear it will fail because now we have different schemas. So the first one has now 30, while the second one, the history table, has 100. That does not match, and that means it will not work. Okay, now we are thinking we are smart. Don't do this in production, really, don't do this. I update my history table and say, hey, come on, all the rows where we have more than 30 characters in the street, reduce them to 30. You will change history data, keep that in mind. But now, when it's all down to 30, maximum 30, I now can change the metadata of the history table, and then I can switch on versioning again. I wouldn't say it's a good idea. It's stupid to do that because see this, what happens here. Yeah. So now all the old data has been truncated. You have changed you have changed temporal data. And if your database will be used for forensics, it might be that you really run into trouble when you're working in a German bank and you're doing that. Because then you're manipulating history data. So you see that changing metadata from existing data might be a little bit tricky. It will work, but only with hardcore workarounds. And always keep in mind that you sometimes must change the history data, and keep in mind that it might be that it's not allowed in your company to do that. So renaming columns, the question is, will that work? The answer is yes, it will. Renaming objects, metadata, is a very simple thing, but there are a few tricks what you need to know. I go into my customer orders, and then I create again my demo table. Here it is. So I have the original one, and see now what is the relation between the demo customers and the history. And you can see very clear here that it say, well, the demo customers, that is my leading system. It's system versioned, and it's a so-called system versioned temporal table. And this is my history table for this. This is the ID. So to see this, I forgot this. Here it is. So demo, this is system version, and the history table is exactly this one. So they belong to each other. Here comes the point. What I want to do is I want to rename the demo.customers into demo new customers. You see from the object type, I'm referencing the object. The question is, will that work? That I change here table names. And the answer is very easy. Yes, it will. And this is something where I was a little bit astonished about this, but that is okay, because think about this. System versioning is not referenced by names, but it is by object IDs. You see, this one is missing. The reason is because I have renamed it, but here is the result. Sorry, look to this. Here is my new customer. This is the object ID, but the only thing what we changed is a name, but not its internal identification by the Plenty with trial and error. Thank you. Yeah. Okay, Martha, it's a pleasure. So object IDs, these are the references, but not the names. Okay. What about this? Now I want to rename the history customers to history new customers. And the very easy way is, yeah, it's working. It's very clear because the reason is, again, we are referencing not the names, we are referencing only the object IDs. You see, they never got changed. So the relation between both tables is always there. So in easy words, it's only names. What is a name? Yeah. So see this. Oh yeah, that is funny. Now we want to rename a column of the System Versioned Temporal Table. Means I want to rename the name attribute. Here, let me show this to you. Refresh. Here is my name. And I want to give it a new name called customer name. And the question is, will that work? And the answer is, oh yeah, sure. What will happen here? When you change it, there are two things which get changed, and that is cool. The customer, so the column name will change. That is okay, but what SQL Server will take into consideration is to change it in the depending history table the same way. So no problem with this. And this, to be honest, I don't see really a problem in. Changing object names doesn't matter. It's not as worse as dropping columns. But what about this? I'm now coming from the other side. I'm coming from the history table. I want to change the street to custom street. Will that be working? As the answer is very clear, no, because it is protected. The history table is protected by SQL Server. We cannot do changes on the protected history table. We can only do the changes on the original, on the production table. Yeah, that is something what I think is a pretty good solution. Yeah, we don't want to change the depending objects. We only want to change the leading objects. So now I clear the kitchen, gone. We can now come nearer and nearer to the really funny parts. I hope you enjoyed so far what we are doing here. And yeah, this is so interesting, the nightmare of these triggers. And this is something where a question was raised about it with the username. And by the way, that's exactly the demo I want to show you. How can you add a username? Who did the changes to the row? Nightmare with triggers. And this is just only the sum up here. Nightmare with triggers. The problem with triggers is triggers create duplicate records in history table. Whoa, 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 whoa. You would say, what? What's going on here? The key point is that when you have an update trigger implemented, it does mean that when a record comes in from a regular update statement, it runs through the trigger, which fires another update. So that is the reason why we do have two entries there. And the only way how you can prevent this is using instead of triggers. But here comes the point, they're not allowed in System Versioned Temporal Tables. See how you can play with this. This is really, truly a funny thing. And there are a little trick to do this. So I will go around for my customer orders and I create my demo table again with 87,000 rows. Then now the table will get another column. And this is something what I saw in the chat. An example, there was a question coming up, say, how can you store the user who has changed the record? And this is my demo here. What I'm doing is I want to add a new column, and you see that it must be nullable because I have data in my table. And what I'm doing is I'm now adding a new column called update user. So for this, it's done. Let's see whether it was working. Here, the refresh. Come on. Ah, sorry. Yeah, that is true. That cannot work. make a refresh on the tables. Then we have the DBO customers again. Here's my column. And you see, I have my update user in it. Cool. Now, these are my data. And you can see update user is empty. So these are the original values. They are valid till this timestamp up to the end of the world. And now I create my trigger. So developers will very easily understand what's going on here. I create an update trigger. And what I'm doing is I run with an update on a row. Then the trigger jumps in. It's for an update. And then it says, hey, stop. I take the row, which has been changed, and I update it again. You see, this is a separate update command. And I say, please, the update user must always be the original login, that I see who has changed it. I implement this trigger. Now we are ready to rumble. Here are my data. Let's see what's going on with the customer with the ID number 10. It's this customer here. And you see this don't have an update user. The reason is we didn't change any data so far. Now I run this. I change the name of the customer with the number 10. Go for this. Goes very quick, but I have full flash disk. I have 8 cores. It would say very easy. Now I run this query here. Say, please give me all the data, including the history data for the customer with the ID number 10. Look to this. Here it is. What will you see? You see 2 rows. Normally, I would say that you might think, Uwe failed. Uwe said, hey, a trigger will create 2 rows, but I don't see I don't see here 2 rows. I see the original one here and the new one where you see the update user. What has happened here? Well, the key point here is I look into the history table and look to this. Here you see the 2 rows. And another thing happens. Look, please, to this here. This is important. You need to understand the valid you need to understand reading the valid from valid to. And when you see this, you will automatically suddenly see what the problem is. You see that the valid to has exactly the same timestamp. So, and that is something where you might say, but what? Stop. I run an update on the demo. Afterwards, whether it is a millisecond or it is a picosecond, it doesn't matter, but there must be a difference in the valid to, because then the trigger jumps in and the trigger did the second change, this one here. But both ended here, valid to, sorry. Both ended exactly at the same time. The key point here is that SQL Server will not store the time when we changed the data, but it will store the time of the transaction. So when the transaction starts and stop. These are the key points for SQL Server to store these information. But back to this point, we see here that we have 2 rows from the former row. And this is, from the history point, the following. The original row was this Tippery-Moore worldwide customer. We run an update on it on that time. Then we changed it to DB Berater. That's my company. But think about how we change it. We only said change the name. Afterwards, so this is my update statement. But then the trigger jumped in and run another change on it, which means that this one is not anymore valid. So we pushed it down to the history table, and the only valid row is this one here. This is the last one. This is the change coming from the trigger. And see what that does mean for you. So whenever you have triggers implemented in System Versioned Temporal Tables, you will, in that moment, double the number of rows in your history table. Ooh, that's cool. Think about that when you change 10,000 rows a day. That will be fun, yeah? But the good thing here is go to your manager and ask for more storage. That's the point. Or go to your manager and ask for raising your salaries because you have a very cool idea to prevent this. Let me show you how you can earn a little bit more money. Here comes the trick. First of all, I drop my trigger. So, and then, you know, one of the big points was, and let me go back to this, have a look to the second bullet point. Instead of triggers are not allowed in System Versioned Temporal Tables. Hoo-hoo, we say, no worry. What we do is we create a view. This view is exactly or represents exactly the table. Then we create an instead of trigger, but not on the table, but on the view. Go for this. Execute. Now we play again with the data. I take number 11 because 10 is now, it's that. Yeah? So we take number 11. See what data we have. Here is my number 11. We see all the data. There is no changes. This company, this great company, Adverpomics Worldwide. Now this is the actual row. And I change now, not my table, but have a look to this. I change my view. And you know, instead of triggers are not allowed on the table, but I put it on the view. And now there is something weird happening. SQL Server now will run over the view. The instead of trigger stops or it's preventing going directly immediately to the table and change the data. But the instead of trigger now is responsible to store data in the table. Look to this. So you need to know how instead of triggers are working. An instead of trigger requires you to run the original statement, what should be run inside the trigger. So that's what I'm doing here. I run this update. Now on the demo customers, I say, run an update and please put in update user. Ho, ho. And now when I run this update, everything is well. Look to this. I say, give me all the data. Great. Looks the same as before. But look to the history. And yay! Only one row. That's cool, yeah? So with a little trick, you can handle this. One of the key points here is that you normally cannot do this with vendor-driven applications. But if you have your own applications, think about this. Yeah? Using views, yeah, eat less tables, eat more views, or store procedures, functions, whatever you want. So just remove this. It makes so much fun, you know, when you see what's always going on with temporal tables. This is really sometimes a bad thing, but the cool thing are the workarounds, how you can cheat these temporal tables. I will skip the security features because I wouldn't say they are boring, but let's wait for SQL 2022 when the dynamic data masking will see a few improvements. So I will skip this and I will go over to calculated attributes. Do I have the time? I hope so, yeah, but I think yes.
For you, we can make the time.
Pardon?
For you, we can make the time.
Oh, that's great. Okay, yeah. So a normal movie will take, in the meantime, 2 hours, 15 minutes. So I'm nearby. Yeah, we make Ben-Hur, which takes 3.5 hours, but I promise I will not take so long for this. Calculated attributes, another big point, because I see so often, I hear so often the requirements that people want to have calculated attributes using them as indexes, because maybe a few of you know that, for example, the fantastic feature in Oracle, these calculated, what is it? No, this an index feature where you can use functions and indexes. This is something what we cannot have in SQL Server. So that is one of the reasons why many people are trying to do workarounds with calculated attributes. So that means we put a calculated attribute in our table, put an index on it, and then it works nearby the same as these kind of indexes as it is in Oracle. So calculated attributes will have some pitfalls for you in temporal tables. And we want to go through this. Come on, I find it. Here we go. So close this one, and we go now a long-running calculated attributes. Here we are. Ho, ho, ho. So again, you see it's always the same. And I create my table called demo.customers. Here we are. Nothing has changed so far. I'm going to update the queries. You see, yeah, it's the original one. So now we come to a point where we say, okay, I want to have a calculated attribute in it. And the key point here is, will that work when we have System Versioned Temporal Tables activated? The answer is very simple. Oh, yeah, I see it here. Okay. The answer is very simple. No. System Versioned Table modification failed because adding computed columns, and let me mark it this one here, while system versioning is on, is not supported. Okay, we say, hey, Microsoft, we understand. Yeah, and let's try this. We are Chuck Norris, and here we go. I start my transaction. I want to have it all in the transaction. And here we go. The good thing for this way to do that, by the way, for you all, for DBAs, for example, is when you put it in a transaction and you want to change or want to manipulate historical data, when you switch off system versioning, it's part of the transaction. And as long as this one is working, you have a schema modification lock on the table. That means nobody can change, insert, update, delete data in this table. So I set system versioning off. Now I do this. I add a calculated column in this table, demo.customers. You see, very simple. Take the street, make a comma, zip city. Very simple. I then do exactly the same in the history table, because you remember, data in the history, or sorry, metadata in the history table, they must always be exactly the same as the system version table. So that's what I'm doing. I add this one. Next step, make system versioning great again. And then, oops, setting system versioning to on failed, because, yeah, this is one of the points. We have computed column specification. What the heck? Consider dropping all computed columns. So, and that is definitely one point I've mentioned before. Calculated columns are not allowed in the history table. Okay, roll back. Okay, yeah, that was automatically. That's clear. Third approach, because we want to have a calculated attribute in our table. It is required by the business. So what can we do? There is a little trick. I start again my transaction, and the only thing what the previous error message mentioned was, hey, you are not allowed to have calculated attributes. Okay. I switch system versioning off. I add my column, my calculated column. Now I'll do a little bit of math. have a look to the maximum size. So what we have is the street is a varchar 100 here. And I add at least a comma and a blank, a space in between. That means we have 100 bytes plus these 2 bytes. Think about this, when it is an N varchar, Unicode, add 2 more, okay? Then we have the zip file and we add a blank between after this. That means we have a character 5 for the zip, plus 1 makes 6. And we have the city which is a varchar 100. So this is a calculation you must do. And now I add this, it's in, okay, yeah. Now I have added the calculated, but now we come to the point for this history table. The point is that the history table cannot or will not allow calculated attributes, but okay, we make it persistent. So 100, 200, 5, 6, 7, 8. I add the same name, full address, and make it a varchar 208. That works. And now I reactivate and let's see whether it is working and see, ta-da, bang. It is working. Also, and that is something quite interesting here, that's the interesting point. In the online help, you will always see that the system versioning requires the history table to have exactly the same metadata as you have in the system version table. But this is not really true because now we have here a calculated attribute. Okay, from the perspective of data length and data type, it is correct. But from my point of view, it is a different kind of column. The first one is calculated and the second one is persistent. However, we commit the data, go for this, and we check this. I update my customers, the ID with the number 10. This is, by the way, my personal address. So if you want to stalk me, just come over to Europe. You're always invited to come here to Germany, near Frankfurt, for a beer or for a chicken. So execute. Bang. That's okay. So I've changed it. And now let's see what happens to my data. You see here, I have the full address in it, execute, and yeah, it works. So here's my full address. The first one, the original one was 41 East Whitehake, but now it is this one. And the good thing here is that SQL Server can work with this kind of metadata because it takes the calculated value and stores it permanently in the history table. That works pretty good. So keep always only in mind that when you're dealing with calculated attributes, that you must have these data stored permanently, so as a regular column in your history table. So clear the kitchen, everything's done. And now come to the last but the most interesting thing. One thing to calculated attributes, System Versioned Temporal Tables can use, you have seen this, as long as System Versioned Temporal Tables is implemented, it is not allowed to add calculated columns, because that means that SQL Server wants to apply the changes one-to-one to the history table. But that won't work. So therefore, the history table or the system version must be deactivated, and the history table must store the data in a persistent column, or in a persistent, oh, there is a typo in it. I will change it. Always think about the rule that the metadata in the history table must be the same as in System Versioned Temporal Tables. So that does mean for you that whenever you're using calculated attributes in your System Version table, do a little math, think about the new data type and data size. And then nothing can go wrong. Everything will work well for you. Yeah. And yeah, oh, that is a cool thing. And this was something we were running into big problem, really big problems with a customer, and unfortunately, I have to admit, unfortunately, we had to stop system versioning for that project because of exactly this reason. My customer was complaining about Microsoft, but I said, stop, guys. That is not correct. It's not a problem of Microsoft because that is how it works. Here comes the point. System versioned temporal tables can be really problematic if you have long-running transactions with heavy workloads. The key point for storing the information up to what date a record is valid is referencing the transaction begin time for the history data. So what does this mean? Here is the scenario. You see it here that we have the transaction number 1. It starts at a point T1. Now my query is running, and look to this. While my transaction is running, I never touch my demo.customers, but as long, and I think that you all know this, as long as I do not touch my customers table, the resources are not blocked. So while my transaction is running, and it's going on, it's going on, it's going on, suddenly a second transaction jumps in, makes an update of a row in the customers table, and this is the point, the transaction number 2, it commits. In between, there were no changes to that row here from my transaction number 1, the long-running transaction. Afterwards, so transaction number 2 has finished long time ago. My transaction number 1 jumps in and is changing exactly the same row again. And then we are coming in a conflict, because what will happen here, and before I explain that to you, let me jump to the demo, because when you see what's going on, you can clearly understand what the problems is and how you can resolve this. There is this I can take before is there is just only one chance to do that. If you want to have system version temporal tables and you're dealing with long-running transactions, there is only one chance to avoid this scenario. You must run in serial. And this is the question whether it is you want to use it or not. But however, let's see how that works in real life. This is a very strongly simplified demo, because it was a little bit more complicated at the customer side, but here it is. I go into my customer orders and I create again my table with 87,000 rows. Done. Now I start my transaction number 1. I begin my transaction, and before I do an update or anything, have a look to this. What you see here, what I want to show you here is the transaction start date. And the transaction start date does not start with the first update. No, it starts with the begin transaction. Execute this. And look to this timestamp. And it is, in my time here, 7:43. Okay. Now, the original process was running a very long transaction. Very long. And what I want to do now in between is this one. I take this statement because now I want to simulate this long-running, this short transaction. This one, what you see here, is my transaction number 2. Please keep in mind, we both change the same record, but here we are at that point We have a long-running business process. And this update on the ID number 10 will come. But before it will come, it will happen here. Go for this. Look to the transaction begin time. There is 1 minute later. Here is the new row, and this is the old row. You see that the old row is valid up to 5:44. So since 5:44, the actual row is this one from my wife, Beate Ricken. Okay, the transaction is committed, and now we come to this. The long-running process, Gandalf was walking along the way, and now he comes to Mordor. We do the update, and we will fail. And that was happening multiple hundred times a day with our customers. Have a look to the error. The data modification failed on System Versioned Table because, keep that in mind, the transaction time was earlier than the period start time for the affected record. You remember when I ran this query, it was 543, but here we are in a transaction, sorry. Let's go out of it. Commit transaction, shit. Have a look to this. Beate Ricken was the last change. That was 1 minute later, before this transaction was coming to the update statement. And that was the problem here. That is the reason, excuse me, that is the reason why it didn't work well. So what can we do? Let me do this, please, only here in pseudo code. But what we have to make sure is before we run our long-running process, the only way how to prevent this issue is you run a select star on demo.customers with update log, where Mr. Ricken from, you see it's late here. I'm old and this is normally my bedtime. So where ID is 10. And with, sorry, I forgot something, hold log. What will happen here? When I would change my code this way, I will say, I start my transaction. Now I block the row which I want to run an update on later on with an update log. Update log means others can select, but nobody can write on that row. The hold log makes sure that it's not only while the select statement is running, but while the old transaction is open. So now I have a lock on this row. Then I can start my long-running business process. But keep in mind here that for that time, we hold permanently a lock on it. If this long business process will take 2 or 3 minutes, we are holding the update lock on this row. But that is the only way to prevent these errors with an update on a row which has in between the long-running transaction changed by another transaction. Now, this is something what we have to take into consideration. So close this, go. And that's how it works. So I hope that you have seen that temporal tables are a really, really cool feature, by the way, that you like temporal tables. And on the other hand, you have seen, hopefully, that not everything is so easy as it sometimes get tried to sell by the business. Yeah. So now it's time for some questions, if you have any questions.
So one I know everybody in here is kind of excited to see the answer to the great one from Peter. If there is a GDPR issue with the temporal tables and how that is affected.
Yeah, that is really a good question. So let me think about this. So I know what the problematic with GDPR is, but I would say basically, first of all, not. That's my point of view, by the way. This is like my private opinion about this. I think not, but it needs to be deleted completely. Yeah, from that point of view, it might be a problem, but to be honest, normally I would say it is not, because what you then need, and Peter has the code in it. We do this, you say alter table, set system versioning off, and then you delete the rows, because that is the right in GDPR for a complete forgetting about data of your personal information. Yeah, but Peter, that is exactly the point what you only can do here. You have to do that manually, yeah.
Cool. So yeah, it's nice to see that it truly is only manual. It's not a quote unquote automatic process.
Yeah, and you need to know. So to be honest, GDPR, we as a Europeans, we know how to suffer, by the way, and GDPR is a monster, because for this privilege to forget your data, what will you do with old backups? Think about this. So all the data are in the old backups, and so yeah. This is a problem, but you see, so Peter has shown a way how to handle this, and I think there are lots of workarounds. So if someone wants to have deleted their rows or their data, and you have system version in it, then you have to make sure that the system version rows are deleted the same way. There is another question from Brand. What about temporal tables and transaction and merge replication? Hey, that's a good thing. If you have a replication, you cannot use temporal tables. That cannot work. That is not working. I was trying to play around with this to find a workaround, but to be honest, I was not following very much, because so officially it's not supported. So why should I take this into consideration? Bad thing is, so if you have a merged replication, you cannot use temporal tables. Or other way, if you have temporal tables, you cannot use merge replication. Not the way around. So if you have merge, you cannot use. So if you have temporal tables, you cannot use replication. That doesn't work. Yeah. Any more questions from you? The night is short. It's 8 p.m. here in Germany. The sun is going down, so I have another few minutes for you.
Truly, I think you have blown everyone's mind. I've seen lots of great questions this entire meeting. Lots of good things to think about. Lots of wonderful reasons to use temporal tables, and some not to use temporal tables. So everything is great.
Yeah. So from my point of view, temporal tables are a pretty good feature. So you see, I have only concerns with one or two issues, for example, dropping columns, by the way, but in general, I think it's a pretty cool feature. And if it is required to store data for forensic data or for any other reasons, then I would definitely say before you do that manually, just take temporal table. The way better they have implemented it.
Yep.
This on all columns. Can we? There is one question again from Sam. Let me see this. Does system track the? One moment. Does system track the changes of all columns? Can we choose the selected column instead of all? Oh, that's a good question. Yeah, I understand it. Yeah, Sam. short answer to this, you cannot control this. Everything, all or nothing. So when you have temporal tables in, there is no chance to say, oh no, I just only want to have it for this column. For this reason, then you have to go to enterprise and use change data capture. But that is a different thing.
Cool. So
okay, everyone, then I would say successful, finished in time. There is a question from Sam. What is the difference between CDC and temporal? Well, let me try to cover this in only a few minutes. Temporal tables are based on the transaction you're in. So that means when you do an update on a row, then the transport of the old data into the history table is part of this transaction. CDC, change data capture, is working in a different way. Change data capture is not transporting data in the moment you change it, but change data capture will read the changes from the log. So there is a log reader, and that transports the data into the CDC tables. But CDC tables have from my point of view, have a really good thing. You can define the columns you want to have. I was doing a session on the PASS Summit in 2015, and I know that Redgate has all the files, all the videos, and maybe, I'm not sure, but maybe you will find my session on the Redgate sites.
Awesome.
Okay. I think we're done now, right?
Looks like it to me.
Yeah, that's great. So a big thank you to all of you. It was really a big pleasure for me speaking here for this user group. And Kevin, my offer to you is, if you want to have other interesting stuff like partitioning in high transactional systems or something like that, just let me know. The time is pretty good here because 6 p.m. in our time zone, that's perfect. That will fit to you. If you have if you would like to invite me anymore for another session, feel free to drop me an email. I'm really happy to present again for you.
Sounds like a plan.
Okay, everybody, then thank you so much. Have a wonderful day. And yeah, maybe we see us again next time here or in Seattle when the PASS Summit is going on, or in London, SQL Bits, however, and all around the world for you with SQL Server. Good evening from Germany, and have a wonderful day. Bye-bye.
You as well. Thanks, you. So with that, everyone, be sure to come to our next presentation next month. And until then, we'll talk to y'all later. Thanks. Have a great day, a great week. Bye.